Yes, it is. She's right. It is.
Okay, so screencasting for people who are gone. Just the quick poll questions so you can hear our discussion. All right, so axis of symmetry. If you look in your notes, the axis of symmetry, you find it by doing negative b over 2a. So what is the b here? What is the b? B is the coefficient in front of x, and it is 6. Negative 6 over 2. What is a?
1.
1. It's the coefficient in front of x squared. So what is negative 6 divided by 2? Negative 3. Did no one submit? Do you guys have to submit it?
How?
How do we see that?
So at the top it says quick pull. You click it, there's a drop down menu and push submit.
Clear.
So if there's a little drop down menu, click it and it,
Submit.
right, it's only one
I
question.
did it.
How do you submit?
There's a little drop down menu at the top where it says quick pull. Click on it.
And then click number 1.
Yes. No, where it says quick pull. Click on it.
Click number
And
1.
then submit.
Just submit.
So I have to send it to you like one question at a time for you to submit. But the submitting allows me to see like, are we done? Are we still working? So here, 7 people submitted, so I'm gonna stop the poll and we're gonna just go on. All right, so I'll stop the poll. Let's see, did we get it right? We did it together. Blessed, you guys all got it right. That's amazing. Look at you getting hundreds. All right, ready? It's the same function. Okay, but I want you to find the vertex. How do you find vertex? Just think about it. So it pops up for you. Just find the vertex.
All y'all got it. Someone gonna call.
Hello.
I think
So you just, what do you do?
I remember it.
I forgot.
Let's see, which page is this on?
5.
5. Page 5 at the top, it tells you how to find it. How do you find the vertex? You use your x coordinate, negative b over 2a, which we just found was negative 3. And then to find the y coordinate, substitute the x coordinate into the original equation for y.
It equals.
So if I plug in f of negative 3, let's see, negative 3 squared plus 6 times
the
negative
last one.
3 plus 9. I put some trick plays in here for you. If you forgot, if you put the negative on the outside, you would get one answer. If you flip your x and y's, you get a different answer. Tricky trick. I'm seeing if we can do it. And once you're done, of course, click submit for me. It's a little drop down menu at the top. Waiting. 4 people have submitted. Hello, Eli. All right, so we're just going through some quick poll questions. What's your lesson plan? All right, so if I go through, what is negative 3 squared? Negative 3 times negative 3 is? 9. A negative times a negative turns into a positive.
18.
Minus 18 plus 9. Wait, this is equal to?
0.
0. So it always goes x, comma, y. So negative 3, comma, 0. It's D. So I'll go ahead and I'll stop the poll. We should answer already. 5 people submitted. 6.
Oh, wait. I forgot to submit.
Do. Okay, I'm stopping.
You have homework on the quiz.
What?
The quiz is coming up.
You have to show your work, yes? Was that your question?
No. The homework on the quiz that's coming up. We have to turn it in
Yeah.
on 11-8.
Yeah.
Okay.
So I think we've established a solid routine first quarter where the homework of the chapter before the quiz is due with the quiz. The homework between the quiz and the test are due day of the test. All right, so without graphing, does this function have a min or a max? Without graphing, how can you tell? Think about it.
I didn't see that.
Min.
It's popping up.
Oh, there we go. There we go.
So think, how do we know? How do we know if it's going to have a min or max?
False or negative.
So if it's a positive or negative number in front of x squared, is it positive or negative? Positive. So what will it look like?
Minimum.
It's going to be a U shape because it's just going to be a regular nice parabola. And so if you look at it, you're like, wait, you go down and then back up. You're going down to a minimum and then back up. So you just have to look at the coefficient, the number in front of x squared.
Also, the axis of symmetry
So-
really doesn't work because the axis of symmetry could be in this negative, but it could also be in maximum.
You do, if you're not logging in, you just need a hat. If you're not logging in, you just need a hat. Okay, so how do we know it's going to be? We look at the number in front of x squared. It is positive, which means it's going to be a U shape. If you're positive, you're smiling, you're going up, right? You're happy, right? The smiley face literally looks like this. So if it's a positive coefficient in front, it's going up, and you go down to a min. If you're negative in front, you're frowning, you're angry, right? A negative in front, you're frowning. The parabola points down, and so you go up to the top and then back down, so it goes to a max. Okay, so hopefully everyone selected which one?
Maximum.
Maximum. What? Minimum. It goes to a minimum.
Mr. Brian, are you here about that?
Okay, bathroom pass.
Thank you.
All right, and the last question. What is the range for this function? So you will have to insert it in. And hint, you're going to have to use an inequality. So think about how do you write an inequality. All right, how do you get to inequality? You have to push Control equal in order for you to insert an inequality, just to be clear. Okay.
Don't we have to put it in a table?
No. So the range for this function, so think about, we said it goes down to a minimum. All the y values are going to be above that. So I can say,
Wait, how do we get it?
so if you do control the equal sign, that's how you can get the inequality symbol. So it should be y inequality, whatever the min or max was.
I forgot how to do it.
So literally, if you go over here and push y, and then push Control equal, think about which inequality we should be using. So we said we went to a minimum, which means all the y values are going to be above or equal to. What was my minimum? What was my minimum value? 0. Right. The range is y is greater than or equal to 0. Because if you look at this graph, right? Not this one. Look at this graph. This is, I go down to a minimum, and then it goes back up. So the smallest y value I have is 0. All the y values are going to be greater than 0.
Is it always gonna have greater than?
Or equal to? Yeah. Yep. Okay, cool. So I gave you the answer. So we submit. Do we submit yet? Let's see. So at the top, there's a drop down. It says quick poll. Click on the quick poll drop down, and then you just push submit. Okay, so I realized that we did most of these problems together, which is fine. Nice little review, because we're going to continue finishing 4.1 today, and we'll start 4.7. 4.7, I mean, it's going to be slightly a review, because we already worked with transformations of a function. All right, so we worked with it before. Hopefully it won't be too bad. All right, do we have questions? This was what we went over on Friday. Yes.
When it's like a maximum, isn't it like y is less?
So if it's a max, it would be y is less than or equal to whatever the max value was.
Okay.
Exactly. All right. Where am I? Whew. Wait, is this? No, it's not even the right class. Oh my goodness. Okay, so we went over this page. We went over how to find this on our calculator, so we're going to review this as well. So max and min values, did we do this page? No. Okay, so min and max values. So this is exactly what we're talking about, where a is positive, so a is the coefficient in front of your x squared. So if it's positive, you're a smiley face, and you'll have a minimum. If it's negative, you're frowning, you're angry, and it will have a maximum. Okay.
Yes, it's always depending. It always depends on what's in front of x squared.
Yep, it just depends on what's in front of x squared. That's the trick. You don't even have to graph it. Yep. All right, so state whether it has a min or max based on A, then find the minimum or max by graphing on your calculator. So we can go through and let's say whether it's going to have a min or max. I'll just start with Lauren A. Will this have a minimum or a maximum? Oh, that was mean. You weren't here Friday.
Yeah, wait, is it Matt?
Let's see. So it's positive. So I know it's going to be like a smiley face. So I'll actually have a minimum. Okay, we can go through and put it on our calculator. So I'm going to open up the calculator. Here we go. Just review how to do this. I just want to go home. Okay, graph. Go to my graph. Oh my gosh. Where do I insert? It's gone. How do I get so I can insert? Tab. Okay, nice little review. Calculator skills. And I have to insert,
Wait,
2x squared?
mine says rel x.
Rel. Okay, so you have to go menu,
Yeah.
graph, entry, edit, function. Because you were in relation. Yeah. So we're in function mode. All right, so it's 2x squared. Let me grab my notes so I don't click back and forth all the time. 2x squared plus 4x plus 7. Okay, so plus 4x plus 7. Plus 4x plus 7. All right, so we see this nice parabola. And we see it's going to have a minimum. So let's see, Ruby, how do I go about finding the minimum? How do you do it on a calculator? What do you push? Menu.
Analyze graph.
Analyze graph. Minimum. So notice it's saying lower bound. That means I have to go left of the minimum. Click. Drag it to the right, to the upper bound, and it pops up where my minimum is. This is a wonderful feature. So -1, 5. Cool. All right, so let's do one more of these examples, and then we'll go on to the rest of the lesson. Because
Mine's not working.
-1, 5. Okay, so try out B. I'm gonna help Dylan. Try out B. See if you can do B by yourself. Minimum. Okay, I'm gonna go left of it.
Before that, this one come
It's me. I am magic. All right.
on. What was that?
-1, 5. Okay, so without even looking at your calculator, we knew B is going to be a maximum because it's a negative in front, which means you're frowny. Sorry, so the U is upside down, so which means you go back to a max and then back down. You don't have to necessarily go through that every time, but it's good so you don't mistake. All right, so negative means it's facing down, which means I go to a maximum. So I go to my calculator, push tab. I can just delete all this nonsense, and it's going to be -2x squared minus 8x minus 5. Is that right? Okay. All right, so I see it's definitely going to go up to a max. So I just have to click menu, analyze graph, but I have to push maximum this time because it's going to a max. All right, lower bound, go left of the max, go upper bounds to the right, and it pops up. Your maximum is -2, 3. Okay, I think we get it. There's 2 more examples if you ever want to come into bonus or the Math Center and have more help. But I would like to do an SAT example. Sorry, do we have questions? Are we okay? Okay. All right, so SAT example, the equation above gives the height above ground, h in feet of a ball, t seconds after it's launched vertically upward from a platform that has a height, that is at a height of 18 feet. Whew. What is the greatest height the ball achieves? Oh, that's crazy, right? But wait, this is going to be a parabola. And it has a negative in front. So what will the graph look like? A U or a hill? It'll look like a hill because it's a negative number in front of the squared. In front of t squared, x squared, whatever your variable is, the number, the coefficient in front of the variable squared, that's what we're looking at. So -16 means it's going to be facing down. And this is showing how high you are above the ground. Okay, what I would like to know is what is the greatest height the ball achieves. How would I find the tallest height? Where am I looking?
Find the maximum.
Exactly, find the maximum. Beautiful. But wait, Eli, how do I find the max? What do I do?
Graph it.
Graph it. Wonderful. Oh my gosh, you guys. Okay, let's put it in here.
Are we gonna have these calculators?
So you have these calculators during the PSAT and SAT. Yeah. So I'm trying to really help you guys like leverage them. So it's negative 16. There'll be like a graphing question of a parabola where I won't let you have the graphing function, like the graphing calculator, because otherwise what I literally watch what happens. People graph it and then they go point by point. Like that's not what I'm trying to test. I'm trying to test like, do you have a basic like intuition for what a parabola should look like? Can we move it? What but like for a question, oh, you were gone Friday, so I would give you like, you have to put x squared instead of t. Yeah, because this is f of x. X is the independent variable. It's f of x, not f of t. So I would give you a question that's like has a bunch of decimals, kind of like on the last test where the last one was a calculator skill. You'll have a calculator skill on this test.
When are they getting graded?
I have 4 more people who need to take the exam between basketball and extensions and yeah. Okay, negative 16 t squared. Do I have it? What was the rest of this function? 24t plus 18. Okay, 24t plus 18. T plus 18. Oh, shoot. I didn't mean to put a t. Should be x. Okay, so this is crazy. Like, I don't see the maximum, but I think I can still figure it out. So let's find it. All right, so menu, analyze graph, maximum. I could zoom out, but I'm pretty sure it'll just find it for me. Oh man. Yep, it automatically zoomed for me. It's pretty sweet. Because since I could see like where the graph was, I just went to the left of it and to the right of it. Now, if you want to change the zoom, you just go menu, window, zoom, and then you can change where the center is. I can zoom out.
I have a question.
I can go menu, window, zoom. I could say fit the data. So that's a little better. All right, so what is the solution? What is the maximum height? 27. So go back. It is 27. Woohoo! We found it. Okay, question.
I have a question.
Yes.
How do I find a range? Like, I understand you put y, and then you put a equal.
You want to find the range of this guy right here? Yay? Nay?
Like in general, just how to find the range.
Okay, so we noticed that all the y values are below 27, right? You see that's the maximum, so that means that's the highest y, because that's the maximum.
So it's either lower.
So it's either going to be lower or higher than your max.
And it would be higher than if it was going up. Right?
Yeah, it's a little better.
So if it was going up, it would be higher than.
Oh my gosh, I did not mean to do
If
this.
it's going down, it's lower than.
So if it's like this, y would be higher than it. If it is a maximum, y would be lower.
Got it.
Yep.
And you just put the highest or lowest point on the y-axis.
Yep.
Makes sense.
All right. So okay. Let me go back. Do I still have the notes right here? So we started by doing the axis of symmetry. Then we found the vertex. The vertex always goes in the middle box, and then you pick the numbers right next to it. You go through and find it, and then you just like graph it, whether it goes up or down.
What page is it?
So I'm just looking at what we did. Did we skip this problem last time?
No, we did not.
We did it? Okay. So I'm just trying to show you. I don't have the pulled up notes. This is page 6? Alright, so we found the axis symmetry, found the vertex. We knew I only want the points immediately around the vertex, so that's how you choose the x values to plug in. How do you know if it's min or max? Well, I had you graph it first, but you can immediately tell by looking at the coefficient in front of x squared. The domain for parabolas, all real numbers. If you think about it, the times when we don't have all real numbers are literally an x will not have a y value. Well, guess what? You could pick any x to plug in. You'll always have a y value. But the range, like, remember how I drew up arrows? So I drew arrows like this. Do you have it on your notes? Yeah. So the vertex, the x of the vertex is your axis symmetry. The y of your vertex, y is either going to be above or below the number, the y value from your vertex. It'll either be greater than or equal to or less than or equal to, depending on your graph. All right, so that's what Ashton was talking about. So we're going to start 4.7 today. Perfect. We're going to skip these two problems because we graphed some already. And if we need to, we always can come back on our review day. Yeah. Okay. So 4.7, transformations of quadratic graphs. So recall from chapter 2 that we learned about parent functions and transformations of both absolute value and quadratic functions. So we're on the top of page 10. Recall from, okay, so graph f of x using x squared using a table of values. The specific function f of x equals x squared is called a parent function. We compare other graphs to this original parent function. So we did this with absolute value. Like, I threw in some x squared. Remember when we had all those equations and we're looking whether it goes side to side, up, down, you know, if we had a dilation or not. Surprise. We're doing the same thing, but instead of having absolute value, now it's x squared, parabolas. So we're gonna graph the parent function x squared. So I have an x table, I have a y. So I'll have -2, -1, 0, 1, and 2.
Plug in
So what is -2 squared?
1.
4. -2 squared is 4. -2 times -2 is 4.
Oh.
-1 squared is 1. 0 squared is 0.
Right.
1 squared is 1. 2 squared is 4. So we did this. This is the first thing we did on Friday. Let's go through, plot those points. And is this going to be a straight line or a curve? Curve. Curve. That's our basic parabola. It's literally a U shape. Okay. So, translation. So translation means sliding. Translation means sliding. So we're going to go through the different transformations, different like sliding and, you know, dilating it, compressing it. There's two types of translations. You either can have a vertical or you could have a horizontal. So, example 1, graph the following function on your calculator and sketch using the vertex and at least one other ordered pair. Describe how each graph is related to the parent function. Okay, so do we need to graph it? We already know what's going to happen. What is happening with this graph?
It's gonna do it.
So notice if it's inside the parentheses, inside the absolute value, it's going to be horizontal. If it's outside of the square, outside absolute value, it will be up and down. Since this is inside the square, it's going to be left and right. Which way is it? It'll be left, because it's always opposite what we think. So it's going to be left by 3. And if you don't believe me, we will graph it. So left by 3. Oops, well, okay, you know what? Let's do it. Let's just graph it right now, since my computer decided to do this. Just going to go standard. This is just, okay. Delete, delete, delete. Oops. Nope. That's not what I wanted. Menu. Enter entry. Why is it so slow? So we're trying to do x plus 3 and then squared. Yeah, so might as well just do it right now. So x plus 3 and then it's going to be squared. Yeah, exactly. So it's the same parabola, but we just moved it to the left by 3 spaces. So it's the same parabola, all we did was we moved it left by 3. So I'm going to go back to this. And we know our x, y table from before. -2, -1, 0, 1, 2. And our y values were 4, 1, 0, 1, and 4. But if we're shifting everything left by 3, oh, sorry. Yeah, sliding. We're shifting everything left by 3. So that means all of my x values are going to be going to left by 3, which I'm going to be subtracting by 3, because I'm going in the negative direction. What is -2 minus 3 is? -5. Oh my gosh, I need to redo this line. Yeah, I know, it sucks. -1 minus 3 is -4.
3,
-3.
2, 1.
So everything is just left by 3. All of my x values are just to the left by 3. So what you notice, let's see, -5, comma 4, -1, let's see, -4, comma 1, -3, comma 0. Plotting these points. So once you graph this, I want you to compare it to the graph that we did up above. What is the difference?
Move to that way by 3.
All we did was move left by 3. And since it's a horizontal, it affects the x. That's why I went through and subtracted 3 from all of my base points. Just like, I can't hear you. Hold on. Okay, what?
Did you do -5, 4?
Yeah, -5, 4. So, -5, 1, 2, 3, 4.
So you did the new
-4, 1.
translation.
Yeah, -4, 1. So when I went through and subtracted 3, that comes from this point right here. I know that so I'm going to left by 3. This horizontal goes off the way you think. So going to left by 3 means my x values are shifting left by 3, going -3. So I subtract 3 everywhere, and those are my new points. The y value that used to be at 0 is now at -3. The y value that used to be at 1 is now at -2.
Mhm.
Alright, so literally, I take them and I just move them left by 3. Okay, so, ready? Think to yourself. Don't say it out loud. Just use your brain, in your brain only.
Other way.
What is happening in this part? Think about it. Now, turn to the partner next to you. Share. What do you think is going to happen? It's your turn to be a psychic. Alright, predict. Okay, what do we think? To the right. So, what am I going to do with my base points? Okay, so I'm going to say right by 3. So I have my basic points from the parabola. These are the points we're going to use. -2, -1, 0, 1, and 2.
You get to just pick those, right?
Yeah, these are, because the basic parent parabola,
And
that's where I got them from.
those are like,
Exactly. I was going to say, what do I have to do to my x value? So everything's going to the right by 3. So all of my x values, what used to be at x equals 0 is now going to be
plus.
at x equals 3.
4, 1, 0, 1.
So this is from the parent function. -2 squared is 4. -1 squared is 1.
Squared.
Yep. Yeah, the values I got are from x squared. Because remember, we're doing translations. All I'm doing is I'm taking the original function and I'm sliding it left and right. That's all I'm doing. As Dylan said, just gonna, since everything's moving to the right by 3, I will just go through, add 3 to all my x values. That way I have my points. Notice I'm not actually plugging into the main equation. I already had my points from my parent function. Okay, so -2 plus 3 is 1. Oh my god. Why is this not working? Okay, -1 plus 3 is 2. 0 plus 3, 3. 4, 5. So everything is just shifting to the right by 3. So I go to 1, 4. 1, 4. 2, 1. 2,1. So what I'm looking at are these, I'm plotting these points, x comma y. So all I did was I shifted my x because I'm sliding my whole graph over. Okay. Are we feeling okay about this? Because this is, I mean, okay, so I really tried to structure this year so that way, like, you already knew what was going to happen. So you were like halfway there already. But then this part, like, this is the new portion. Like, you knew from before that this was going to be shifting to the right. But, like, how do you show that, right? So I gave you the base points. And then, since it's only horizontal, if we're shifting right, we're going to be adding however much we're shifting by. If we're shifting left, we'll just subtract however much we're shifting by. Like over here.
Do we only do that when it's like squared?
So these points from my parent function, these ones right here, it's because it's from the parent function that's squared. So remember we did this with absolute value. It's just, we knew, oh, we just went off the slope instead of like giving you a bunch of points.
For what we did before, we wouldn't do that.
For absolute value? Is that what you're talking about? Or are you talking about section 1? So this looks different. If I would take x minus 3 times x minus 3, I would FOIL it out. I would get a quadratic, but because this is it's called vertex form. So when we have vertex form, you can use this way of graphing. If you have it, so it looks like this, I mean, you would probably have to just graph it the way we have been. Yeah. With finding where the vertex is, picking points around it. So vertex form, you have x plus or minus a number squared if it's a horizontal translation. All right. So what is happening here? Do we know?
Mm-hmm.
What is it?
It's going up.
Up by 3.
Yep.
But wait, how do you know it's up and not left or right?
Because no, the parentheses.
Because it's not in the parentheses. It's not part of the thing that's being squared. Right? It's not inside the thing being squared. It's not inside the absolute value symbols.
Mm-hmm.
You guys kill me. Just think, if this is boring or too easy and you already know it, if it's solid, that means you should get an A on the test.
Yes.
Should. Okay. So let me list out my xy coordinates from my parent function. So the ones I'm listing out are going to be from x squared. So -2, 4, -1, 1. I got the y's because I just squared my x's. So this time though, I'm shifting everything up by 3. So my y is increasing by 3. So I will go through and I will shift every y value up by 3.
Could you pick the numbers for the x?
You don't have to necessarily do these ones, but
Why
this
the y
is,
value?
but I'm using the parent function value since it's just shifting. If you want to pick like -5, by all means, you could do that. But the y value would be 25
Why
because I want to actually show it on the graph. Yeah?
are you adding 3 to the y side?
Because I have a shift up by 3. So my whole graph, since the 3 is not inside the square,
It's like
it's vertical. It's not what?
It's like the
Since it's not inside the parentheses, so notice that this is inside the parentheses, this one is not. If it's not inside the parentheses, it's a vertical. It's y. So if you have like your parabola and then you shift it up by 3, I'm not changing the x values. What I'm doing is I'm moving the y up by 3. So I'm shifting all the y values up by 3, and now I can find my new coordinates. So I have -2, 7, -1, 4, 0, 3. Okay.
So basically what you're telling us is to use that -2, -1, 0 1, 2, and then 4, 1, 0, 1, 4, and modify that to whatever we need to in order to get our answer.
Yeah, pretty much. I mean, I didn't have to go through and plug in and like find all these new values. Since I'm doing a transformation, I have the parent, right, the -2, 4, right, the general ones, and then I say, okay, how am I changing? Oh, I just have a horizontal or a vertical move, so I show it, and then I immediately have my points to plot and draw the graph. Okay, so what is happening in part D? Discuss with your partner next to you, see if you agree, and then ask your partner how they would go about finding the points. How would they find the points? Okay, so we start with our points from our parent graph. -2, -1, 0, 1, 2. And then all of the squares of this. 4, 1, 0, 1, 4. So I heard a bunch of people say it. You know that this -3 means it's moving down by 3. Okay, so you knew that before this chapter started. Now the question is, how do I show that? Since I'm moving all my y values down by 3, Eli, what did you guys say?
Subtract all of my values by 3.
Exactly. Subtract 3 from all of my y values. Oh my gosh, I didn't leave myself enough room. This is going to equal 1. I messed up.
Just right below it.
Messed up. Ah. Nah, it's not. Okay, you know what? I'm sorry. I'm going to have to write below. 1. 1 minus 3. -2. This is -3.
-3, -4, -5.
What?
Or no,
-2 and 1. So it's still symmetric, right? Do you see how what's our vertex here? What's the axis of symmetry here? Where is the axis of symmetry?
Down 3. So it's -3.
So here the axis of symmetry was at 0. X equals 0. Where's my axis of symmetry here? And my D?
3.
It's also at 0 because I'm not moving horizontally. My axis of symmetry is still at 0. All I'm doing for my parent function is moving it down.
Moving the y values.
So I wanted you to see my -3 and then it's symmetric as I go around it. Okay, maybe you see it, maybe you don't.
I think it's like AOS.
Yeah, AOS, axis symmetry. That's perfect. That's what I'll be using. Okay, -2, 1. -1, -2. What? You could plot it using AOS here. I mean, technically, but so remember the B and the A, it comes from AX squared plus BX plus C. It has to be in that form. C and D, the part C and D here, they are in that form, but A and B weren't. They were in vertex form, not general form. Okay, let's see, 0, -3. And then I know that it's symmetric. Okay, so it's going to look something like this. This was really off. That was not a good one. Up, curve up. Okay. Do we have a question so far? Will you please pay attention? Stop distracting people. If you're going to distract yourself, go behind so the people behind you can see better. Either you stop or you can leave the room. Okay. Here we go. Next one, reflection. A reflection is literally a mirror image. It's literally mirror imaging it across an axis. So a reflection is a mirror image. Reflection is a mirror image. So graph the following functions, blah, blah, blah. We don't need our calculator. It's fine. Ready? F of x equals x squared. Do we know how to graph this?
But you wrote
Mirror image. Yeah. So we already know what the values are going to be. -2, -1, 0, 1, 2. And the reason I was having you do this again is I want it to be super close by so when we do the other part you can see it. So a nice little practice graphing just the parent function parabola.
That's all.
That's all this one is. So the point is I'm trying to show you is which way is it facing? Up. It's facing up. This is what I want you to see. Okay, faces up. Maybe I need to change the wording on this. Faces up. So,
Because
it's just
no
a,
negative.
it's just exactly. And the negative in front, what's going to happen with B?
It's gonna face down.
Exactly. It's going to face down. So hopefully it's going to face down. So we already know what it's going to look like. Let's use our xy coordinates from our parent function just from the general x squared, and then I'm going to see how do I modify them so it reflects. So I'm just going to go through. It's the same points we've been using. So notice the negatives on the outside. So I already have squared my x, and then after I square the x, I have to make it negative. So what should I do? Do we know? I could go through all my y's and just multiply by -1. What's -1 times 4? -4. Negative. I make all of them negative.
You only have to change it because it's negative.
Because there's a negative in front of it, yeah. So I'm changing the sign. I only change the sign if there's a negative here. Because I'll go through and multiply all of these by -1. Since they all were positive, it made it pretty easy to change the sign, because then you just make them all negative. Now, if I had, so far all we've done is like one that was only horizontal, one that was only vertical, this one's only reflecting. The real problem comes when it's like we have multiple things at once. Maybe I have a horizontal and a vertical and a flip. Like, ooh, but like we'll get through that together. All right, so we see it's facing down. All right, your intuition was correct. Do I want to start? No. So we'll end there. That's a pretty good place to stop. And then that gives us 1, 2, yeah. So we'll definitely, honestly, it'll be like 15 minutes of lesson, and then we'll go over the practice quiz. Cool.